Hi everyone, and welcome back to another BTLO replay. Today we got Typhon, or Typhoon, or Typhon, however you want to say it. Great lab, one of our buddies. But yeah, my manners. Be sure to follow us on X, LinkedIn, and join our Discord to keep in touch. As this is being recorded, we are 4 days into the event. Very, very great energy we're seeing from the players. Reminds me of last year's event. Good times. But yeah, let's get started. Links are going to be in the description box below. And yeah, let's get started. So we have Typhon. You can see the tools right now. Procmon, Timeline. We're going to be using Timeline Explorer quite often. And we do have a blog on Timeline Explorer and our security blue team blog site. I'll probably flash it on here. Definitely give it a read. Really going to help you out in this lab. And we do have a blog on Wireshark, so I'll share both of them on the screen. But yeah, other than that, let's get started. Let's read this scenario. Relatively short. Let's see. I made a terrible mistake. A few nights ago, I downloaded a program called ng-ia-exe from a sketchy forum. It was advertised as the next-gen AI tool that could automate my tasks, but ever since I ran it, things have changed in ways I can't explain. One time when I ran it, nothing seemed to happen. Luckily, I managed to capture the network traffic during the attempt. Now it reappears every time I think I have removed it. It's like it knows exactly what I'm trying to do. If anyone knows how to stop this, please help me. I'm running out of options. Alright, so we got a little short, jam-packed scenario. And relatively 10 questions. So this could be a pretty fun lab. Well received. And yeah, let's get started with it. I'll see you guys in the lab. Peace. Alright, let's get started with question 1. We are in the lab. What is the domain and IP address that the program attempts to connect to? So let's just take a look at what we have here. Okay, cool. So we have many tools actually. And what do we have here? Do we have a PCAP and then we have the program? Okay. Oh, you know what? I think I know what we need to do. Because the program's the question's asking what domain and IP address that the program attempts to connect to. So, boot up Wireshark. You rarely, a lot of folks don't realize Wireshark's actually a packet capture. You can actually capture packets on it, while the main use of it goes into, analyzing packets. So, that's what we're going to do. We're going to filter. Let's see how this works. Let's see. Domain and IP address of the program. Domain. So we'll probably filter for any DNS requests. I'll do it on Ethernet 3 and let's run it. So while that's doing that, we're going to run the program, the malware. So let's run that. And then see where that goes. Let's see. Alright, I think it's... Oh! Okay, looks like... Yeah, we're getting an image. What the heck is that? The boy in the blue heron. Oh, the heron. Keep trying. Okay, that's cool. Alright, so let's stop the capture. We could save it, or we could just filter on here. Alright, so let's filter for DNS, right? Domain name server, see if there's any... Oops. Any reference. So we do have a couple references. Let's see. So we have the site www.bas. You know what's interesting about that domain? That's actually a let me actually show you something real quick. Basilisk. Oh, that's literally the lab thumbnail. I didn't even think about that. I thought it was a reference to our lab from last year. Okay, cool. I didn't think about that. That's actually pretty cool. Cool. All right, so we have the domain, and And then we have an IP address. Curious to see if we could look deeper into this traffic. Oh, nah. Yeah, that's pretty much it. Yeah, DNS address. Yeah, all right, so let's give this a shot. That was actually pretty fun. www.b4s1 Bacillus and the IP address, which we can do a IP lookup actually to see where this address leads us to. Oh, did I put that in wrong? Oh, I forgot the TLD XYZ. Cool. And that is question 1. All right, question 2. And actually, I did end up looking up this IP address. It turns out the ISP is DigitalOcean, right, which is a common ISP used to build C2s, right? If you go, for those that don't know, you could just look it up on Google. DigitalOcean is often abused when it comes to building these C2s. It's relatively easy. Funny thing about it, ngrok as well too. ngrok actually put out a new policy. Actually, we could look it up real quick. Ngrok. Yeah, I think this is it right here. They put out a new policy earlier, where hey, if you want to use our things, you got to put your credit card in, because too many people are using the free plan, and they're abusing it. Right? Look, ngrok is being incorrectly flagged as malware. Right? So same thing is happening to DigitalOcean. So just wanted to share that with you guys. Hackers tend to use these free resources to build C2s. It's relatively cheap and hard to redirect. All right, question 2. What is the HTTP request path and the encoded string returned in the response when the program communicates with the server? Now for this one, I don't believe you could find it in the PCAP yeah, that's nothing here. So you're gonna have to use the PCAP. You're gonna have to use the PCAP in the lab. So what I'll do, I don't think we need this anymore. So I'm gonna just quit. And we're still getting those images. Don't look behind you. I'm looking behind. Oh, got me. Open up this. And there we go. So we're gonna be using this. So it says HTTP request path. In response when the program communicates with the server. So let's do this. Fun fact, when you do IP.addr, this actually filters for communication, front and back, right? Instead of destination or source. Goes for all communications regarding this IP address. We could just copy it. Copy that. Put it on our clipboard. And then we could paste here. Nice. All right, and we roughly got, 11 packets. And yes, we do see some HTTP traffic going on. Let's look into this one real quick. HTTP stream. See what we got here. So on packet 274, we have the client, requesting this host. We have the user agent right here. Not too descriptive. gzip. And we have the server respond with this. We seem to have something in base 64. I believe Wireshark could actually decode that, if I'm not mistaken. Can it decode it? I think it can. Let me see. It doesn't matter. We actually have CyberChef that could actually decode it for us. Not sure if it's necessary, but we could still give it a shot. Load up this. All right, there's our CyberChef. Put that in here. And we get stone glare, right? Which if I'm not mistaken, Bacillus has an ability to cause death to those who look in its eyes. Let me see. Deadly Scare, Stone Glare. Ah, so kind of like a Medusa type ability. Interesting. See, that's why I like these Halloween labs. They're spooky and they're technical at the same time. All right. So cool, Stone Glare. What is the question actually asking us? What is the HTTP request path and the encoded string when the program communicates with the server? So going back to Wireshark. Oh, hopefully I didn't close it. So the request path will be, wouldn't it be join, right? Oh, / join. And then let me actually see if I think it's copied already. Let me just try it out. Yep. And that's the encoded string. It doesn't want to decode it. It wants it encoded. Nice. There we go. All right. Question 3. Now, this question is actually my favorite. I think it's very interesting, and you're going to see why. It's a lot of steps to get to here. So, question 3 goes into try to mimic the server response. There's a script under the tools section that you can use. Right, so the script, let me quickly show you that real quick. We're going to keep this open because we're coming back to that. The script will be under here, fake server pi. And you can actually edit this with idle, which I believe is safe. Let me just load it up real quick. And there we go. Shout out to Lab Creator. They provided places where you have to edit the code, right? So the path, and that was from question 2, right? That join path. And then the response body, we saw that in Wireshark. Pull it right here. This string, encoding string. So let's actually put that there. You can see the binary. And I think I still have it pasted. Yep, that looks good. Cool. So we're doing it line by line because you don't want to get confused on this. I'm just going to save it. Hopefully it allows me to save. Yep. Okay, cool. Everything looks good. Let me just check something real quick. So we have the script modified. Consider how the program locates a server. How you might redirect it to your script. Once this is done, the binary will extract multiple files. What is the name of the DLL that is extracted? So a lot going on. So what we'll do now, since we're trying to build like a server, right? We could run it through the loopback address because again, this doesn't have any internet. We can't reach out. So what we could do, we could go to, I think it's under Windows. Oh wow, there's no space on here. Now where it's at, I forgot. I'll see if this works. It probably won't let me, but we'll give it a shot. XYZ. It probably won't let me save it. Yeah, so let's launch it in admin mode. It might rid the day. Okay, still here. Cool. So let me just double check. So we have the loop back, right? And this is the domain we want it to resolve to. So if we go to this domain, we're gonna load up procmon, which I think is at the nav bar. Let me see. Is it? You want to do this now. Now, again, this is where it trips me up a little bit. Let me go back to the file. We're coming back to tools. It's just the name of this. I don't know if that's an I or 1, so what I'm going to do, just going to copy that, leave it alone. Now what I'm going to do over here, I'm just going to filter, I'm going to pre-filter it so we don't really miss anything. So process name and Paste that here. EXE. Add that, and then we're gonna apply. So right now there's nothing here, which is cool. So now we're gonna run the script. No, actually, hold on. Let me see. I gotta make sure I do this right. Let's do CMD real quick. I want to see if we can resolve to that address. So, all right, I'm back. Okay, it's fixed now. I'm able to ping it now. All right, so let's try this again. Yeah. Okay. I don't know what I did differently. I just must have typed this wrong. Okay, cool. We could ping the site. I already have the... Let me actually cancel this. Clear screen. I'm going to run the script again. Oh, sorry. I have procmon ready. So let's run this guy. There we go. And if you look at the PowerShell, we should be getting, yes, the screen. Cool. Let us do his thing already. I think that's all the events we need. Yep. So what I'm going to do right now, I'm going to export this as CSV. Where is it? Save. And then I'm going to load this in timeline. There's many ways to filter for this DLL. Okay, desktop. I believe we could filter via extension. So we'll see that real quick. Oh, yeah, we could filter for that. So I did have, wow, 250,000 lines. A lot of information here. Let's filter for path. And now within this path, actually, hold on, there's too much going on. We could do DLL. DLL, dynamic link library, and see what we get with that. Oh, but we want to make sure the process, it's, hold on. This right here, because this is going to bring up a lot of other stuff. All right, so what do we have here? We got a lot. Let's just do operation. These seem like basic DLLs. Let's do operation write file. And there we go right there. The reason I chose write file, this goes into writing data into an already open file, right? So the program's been created already, right? And you can see it was probably created at the launch of this program. You can see it's in the temp folder, which is very, very suspicious. Hackers love to abuse that. And temp folder, and it's in another folder called one, and then we have a full DLL called Typhon DLL. Now, obviously, this is not legit. Yeah. Wow. Let's see, DLL. Cool. Oh, right here, look. Typhon DLL. No, I'm good. All right, pretty interesting. So yeah, that's going to be our DLL that was extracted. There we go. Nice. All right, question, what are we on? 4. Which LOLBAS, and pretty much LOLBAS means living off the land binaries and script, right? Native tools, native scripts and binaries on the system, in this case Windows, is leveraged to execute the DLL, which we saw in Q3, Typhon .dll. All right, so which one was utilized to execute that? So we could figure this out really quickly. There's 2 ways. We could actually use procmon, or we could use timeline. It's up to you. So what we could do, I'm gonna remove this. Oh shoot, I didn't mean to do that. Okay, let's see. I'm just gonna filter the operation, and we can set it to process create, right? Actually, let me just reset everything because this is too much going on. Okay, operation, process create, right? Because we want to look at the question again. We want to see which one was used to execute, right, the DLL. So you can scratch these off, right? That's the actual malware. This looks interesting. We'll come back to that later. Looks to be in that temp folder. But again, we're looking for a living off the land binary and script. So it's going to be the ones down here, right? The ones in the system 32. We're going to be looking at these primarily. All right, so conhost, I'm not too sure what this does actually. Conhost exe. Oh, goodness. Are they registering that as a... Oh, console. Okay. So this was a command prompt. So we could skip that for now. Let's go to the other ones. We have ping exe. I believe I was the one who ran that. All right, so that doesn't matter. We have reg exe that deals with editing the registry. We have run DLO, which actually makes more sense, right? Run DLO. Let's actually look that up. Run DLO 32. Oh, what did it just... Okay, it looks like I went to a site I went to previously. I wasn't even paying attention. But you see, this is a Microsoft signed binary used to load dynamic link libraries, right? And it seems like this article is going, and look, it's native, right? Lobas. Seems like it is being used to run malicious DLL. Let's see who's abusing it. Yep. So it goes back when we look at this lab, or the question right here, Q3. That was the DLL extracted, right? And then we have this Lobas, which will be run DLL32 exe being used to execute the malicious DLL. So hopefully that made sense in that case, right? It's kind of like using a native tool to get the job done. So let's skip that. Run DLL32 exe. Nice. All right, question. Let's see, what are we on? 5. During the first execution of the DLL, a specific function is called and a file is dropped. What is the name of this function and what is the name of the drop file? Ooh, all right, so assuming this was used to launch the or run the DLL, we could see if there's any... Oh, hold on. Red key. Okay, so something right here. So we can see the command line. You can see run DLL32 is being ran against the Typhon DLL. And Yure, which is ghost in Japanese, I guess it plays a part of the lab, that is the function name. So we get the function. Let's see. And again, you could cross-verify this with procmon as well too. Let's see. Actually, can we filter through here? No. But you could filter through here and cross-verify with procmon. But regardless, actually, hold on. Let me filter for process create just to show you an example. Where is it? Operation is process create. Okay. There we go. Run DLL right here, and we can see the same thing as well too. And that's the full command line, right? Actually, hold on. Because the question is going into the name of the drop file. Let's go back to timeline. I'll leave this here. I'm gonna go back to timeline and see if we can find that real quick. So let me just erase everything. Name of the drop file. So process name, let's do run DLL. There we go. And we have roughly, gosh, 12,000. So we gotta, let's filter for write file. Let's lower this. We don't want any native stuff coming up. Let's see, where is it? Write file, right here. So yeah, we know it went, it was run against this, but we see something here. We see that spool SV.exe is being written in this temp folder. Let me see if I can take a look at this. So we see that run DLL with the operation write file is writing the spool SV.exe in this temp folder. Now, if you guys don't know what this is, spool SV.exe, if I'm not mistaken, this is a, I believe this deals with printing. I could be wrong. My Siri's acting up. I believe this deals with printing, if I'm not mistaken. Let's see. Yeah, so it manages print jobs, but again, it's commonly stored. And let me see if I can find a quick link in here. System32. Let me just type in the directory. Yeah, System32 or system root. Yeah, but when you look over here, it's being stored in this temp folder. So that's quite strange. Something's malicious going on, right? Going back over here, we believe the drop file to be spool SV.exe, right? Because it's in a strange folder and it's not supposed to reside there. All right, question 6. The program replicates itself in a hidden directory. What is the name of the replicated file? And what is the MD5 hash? So, program speaking of the NGIA, what we could do here, I'm gonna open up PowerShell here. And then I'm gonna run get file hash. Remember, it wants MD5, not child256. Common mistake. Get algorithm MD5, and let's do it against the file. So keep that in mind. What I could do here, actually, hold on, I'm gonna keep that open. Remember that temp folder we were talking about? Where's that located? So it's under our username app data local temp. All right. Actually, I could possibly copy this path. And just traverse there. There we go. Oh, wow. Look what's in here. Jeez. Okay, there's the spool. This is the CVC host. There's the DLL. We got a bin file. We have another exe we're not too familiar with. So what we could do here, DWM. Let me load up PowerShell again. I'm gonna run the same command, but I'm gonna run it against this path, which I hope should be. And then there you go. Look, both hashes are the same, proving that these are the same file, just different names. Going back to the question, let me actually copy this. It does duplicate itself in the temp folder. under a file named dwm.exe. Interesting. Nice. All right, next question. Question 7. Which lowbass, right, living off the land, binary, and script, does the binary use to execute the DLL in the background repeatedly? And what is the name of the scheduled task it creates? Now, if you guys remember, we had a list of, where is it? Yeah, there we go. I was looking for this list. So we had a list of processes that, or I guess programs that are used to create processes, right? So conhost, that goes into the console window. Run DLL, is used to run DLL. But this one, obviously regexe, that's for registry. This one specifically talks about scheduled tasks, right? The only one on this list that deals with scheduling tasks is sch task exe, and that is a lowbass. What we could do, open this up, and you can look at the command line. I'm not sure if this is cut off. There we go. You see the attacker or the program uses that program to create. You see a tn, right? Task name, Tengu task, and we see the script right here, and it goes into other parameters as well too. Interesting. So going back to the question, sc task exe, and the name is Tengu task. Nice. All right, question 8. After the command is executed repeatedly, in the background, the program attempts to upload a file to a specific online storage service. What is the name of the service? Format storage service name. After the command is executed repeatedly, so upload the. Let's try to run the command. Oops. All right, let's run this. There we go, and I think some information went through. Let's just pause it real quick and filter for DNS. And yes, we do have a lot more information. Let's see. See a message of Dropbox API. Dropbox is a cloud service. See another one. We can ignore the EC2 ones because this is a virtual machine. Yeah, ignore the EC2 and Cloudflare. But this one right here, can I view this traffic? Look into it a little bit. No. That's kind of worrying. So yeah, it looks like it's reaching out to some Dropbox API again to upload some certain data. So let's put that in. Nice. All right, question 9. To maintain persistence, under which registry key does the binary create an entry? So again, using the same lowbass list we have over here, you could just look into here and see what happens. So we see the command being used, so they're adding a registry key to this path, value Typhon, and all this other stuff. There's that duplicate file, right? So it seems like a key to constantly run that file. Yeah, this is definitely persistence. Under which registry key? Okay, so it wants this key, the run key. It goes into what programs run at what time. Nice. All right, question 10, final question. What is the name of the registry entry added? Format entry name. Is this going into the value of the key? It might be going into the value, which we can see right here, Typhon. And another way to view this, since we're on the host machine that is being tested on, we could go to registry editor. If we have rights, what's the run key? I think it's on the software. Microsoft. Windows. Is it Windows? I think current version. My thing's not full screen, so I can't really see it too well. All right, there we go. And run. There we go. And yeah, we can see Typhon added right here. Right, so definitely some persistence going on. All right, and that is the name of the registry added. Nice, there we go. Pretty solid lab. Shout out to the creator. Interesting. Hopefully you guys enjoyed this. Again, remember to like and subscribe to our YouTube page. Follow us on X and LinkedIn. We drop videos every Friday at 6 p.m. BST. And yeah, keep up the good work. You guys have a good one. Peace.